In this video, we introduce Cito, an actuated smartwatch for extended interactions. 5 different watch face movements are incorporated into interaction techniques to address limitations of fixed watch face. A smartwatch's small size and wearable context can lead to issues during some activities. For example, when carrying an object with 2 hands, it's hard to read an incoming message without putting the objects down. A watch can be covered by a long sleeve. If your hands are dirty, it's hard to raise your sleeve and check an incoming message. Our proof of concept prototype is modular with 3 actuation modules. The top module has a working LCD display. Actuation motors and sensors are connected to an Arduino controller by a laptop over Bluetooth. Our watch can be actuated in 5 ways: translating along the forearm, hinging on side, orbiting around the wristband, rotating on its normal axis, and rising vertically. These movements can be repeated, like repeating hinge to reassemble a mouth. Different movements can combine together to create more complex movements. For example, rotation with translation, hinging with translation, or rotation, hinging, and translation. Our prototype places electronics and batteries in an external control box worn on the upper arm. To see how this would work in context, we demonstrate how our prototype enables new interactions. Now, when carrying an object with 2 hands, the watch face can orbit around the band to make an incoming message visible. When the watch is covered by a sleeve and your hands are dirty, the watch face can translate out to show a message. If an emergency call comes while you're playing a game and wearing a headset, the watch face keeps rotating back and forth to indicate an emergency call. If a message about lunch arrives, the watch can hinge open and close like a mouth. If an email arrives while you're not wearing the watch, like when you're taking a shower, the face can rotate 45 degrees to physically indicate the missed notification. If you need to use the watch for navigation and messaging, the watch face can rotate to indicate the direction while keeping the display focused on the message. Sharing a picture on a watch can be awkward. The watch can hinge to make sharing easier. The watch can even become one big haptic button. For example, when pressing accept, it can lower quickly to feel soft. If pressing decline, it can lower slowly to feel hard. We conducted 2 studies to validate our idea. In the first study, we showed participants videos of representative scenarios in which current smartwatches may be inconvenient. These videos were created with a passive prototype. Actuation was accomplished by pulling an attached fishing line. Scenario 1 is when carrying a heavy object in front of the body and the watch face is down. Scenario 2 is when the watch face is exposed to dust or water when cooking or gardening. Scenario 3 is when the watch face is covered by a sleeve. Scenario 4 is when notifications are missed when wearing a headset and focusing on a game. Scenario 5 is when notifications are missed when away from the watch, like when you're taking a shower. Scenario 6 is when switching between messaging and a map to navigate. Scenario 7 is when sharing a photo on the watch with a friend. Then participants watched videos illustrating how an actuated watch face could be used in the same context. Face orbits to the other side of the wrist to make it visible. Face hides inside sleeve. Face moves out of sleeve to show a message. Face rotates to indicate an emergency call. Face stays at 45 degrees to remind the user to check the missing notifications. User texts on the watch, and face rotates to indicate direction. face hinges towards the friend. In a second study, we investigated social acceptability and perceived comfort for different actuation dynamics and usage contexts. Participants viewed 3D animations of the 5 movements with different movement amplitudes, cycling options, and speed. Using the animations, they answered questions about social acceptability and perceived comfort. See the associated paper for more details and study results.